Ready to start? A very warm welcome from Unimont in Adolo for joining this, and thank you for joining this seminar, this webinar as well. So it will be performed in a hybrid mode. So there are some people in presence here in Adolo at Unimont site, and some others connected. So thanks a lot for attending this webinar. A very quick introduction from my side. I'm Matteo Vizzarri, a professor in sustainable management and bioeconomy of mountain forests within the master's degree course in valorization and sustainable management of mountain areas of the University of Milan, which is held, this course is held here in Adolo. And today we will talk about the forest biodiversity with one of my colleagues, Giovanni Santopuoli, a tenure track researcher and a professor at the University of Molise in central Italy. And I'm very glad to have you here, Giovanni. Let's introduce this concept of forest biodiversity. We know that diversity, so this biodiversity is basically at the basis of the functioning and of all the ecosystem processes and mechanisms. It underpins as well the provision of goods and services. Just to consider that forests cover more than 1/3 of the total Earth surface on a global scale, and it hosts, so forests host more than 50% of total number of animal species and animal and plant species and habitats. So it's very crucial to understand how these forests, especially in fragile environments such as the mountain environments, contributes to our well-being. Okay, in most cases we cannot see the relevance of biodiversity because we cannot recognize really the total number of organisms that are surrounding us, the health status of the conservation of the habitats in the places that we visit for recreational or tourism purposes. But we feel that this is something important for us and for our health as well. So when we have fresh water available at our sink, in our places, at our sites, at our houses, so we perceive that there is a source of this benefit, and this benefit comes from an health ecosystem. And this ecosystem is in healthy conditions because there are a lot of organisms, a lot of living beings and habitats supporting these mechanisms, these processes. Another example is the variety of non-wood products that can we obtain from forests. And this also obtained because there is a certain number, more than one single tree species, more than one single herb species, okay? As well, we have other products coming out from forests that depend strictly on the availability of many living beings and organisms that that live in such ecosystems. But except for that, biodiversity is also a kind of leverage point, a kind of driver to sustain our processes or efforts to fight against climate change, okay? Because a more diverse ecosystem, more diverse forest also help us fight against climate change because it improves, it develops as well the forest productivity, so the productivity of forest ecosystems. Indeed, there is a strict correlation between a linear positive relationship between higher value, higher conservation, nature value, and biodiversity value and productivity of the ecosystem. Because if we have a large number of components, of ecosystem components, likely we have a large number of outcomes of these processes at ecosystem level. And with Giovanni today, we'll talk about how we will have more or less 3 blocks in this seminar. So we will devote some minutes at the end of each block for questions and answers. And basically, we will touch many aspects related to, for example, the introductory part of forest biodiversity, its relevance, its importance. Then we will move throughout the several methods and approaches to evaluate biodiversity in forests. And then Giovanni will provide us some examples on real cases on assessing and monitoring forest biodiversity. Okay, remember that biodiversity is at risk. So we are losing biodiversity at global scale in any ecosystem, in any natural and semi-natural environment. So a role of a forest manager and planner is also to preserve this capacity of the ecosystem to continue functioning over time and in the future. Okay, so and now I stop here. I will leave the floor to Giovanni. Thanks a lot again for coming and for being with us. And the floor is yours. Thank you.
Okay, thank you very much, Matteo, for giving me the possibility to describe such activity, such a research activity that we are carrying out at University of Molise related to monitoring of forest resources and assessing forest biodiversity. So you already introduced me a little bit. I would like to say that I am a researcher, a forest researcher at the Department of Environment, Agriculture and Food at University of Molise. The region, Molise region, is a small region in the center south of Italy. And yes, I am teaching 3 courses there related to forest management planning, forest inventory, and cartography and remote sensing. So today I will show you some activities that we made within several research projects at the University of Molise. So I can start. Please, if you want to ask something, you can interrupt me, whatever. So feel free to interrupt me. So, as Matteo said, we have 3 main topics today that I would like to show you. And we start with a brief introduction about the role of forest for the provisioning of ecosystem services, with a particular focus on forest biodiversity. Then we go more in depth with the 3 related microhabitats, which are a specific topic that we investigate within our project, because it is a specific topic related to biodiversity. And I will show you some example of case studies related to assessing and identification of this ecological feature on the trees, and all these features are related with the forest management. And then the last topic is the introduction to innovative tools for monitoring forest resources, included also forest biodiversity. So we have a first question. Why is forest monitoring important? As Matteo already said, forests play a multifunctional role for human well-being. Probably you know very well which are the functions that the forest ecosystem plays for society. And I have prepared this short picture displaying such functions, some of the numerous goods and services that the forest provide for society, starting from the reduction of absorption of carbon dioxide from atmosphere, and store carbon in timber products, in the trunk, in the roots, in the litters, so also in the soil. So it plays a very, very important role to mitigate climate change or the negative impact of climate change. Also, it is an important source of timber production, the most important source for timber production. And also we will see later that it is one of the most important source of income from specific territory or specific local area. It is a very important source also for fungi or for other elements of forest biodiversity, such as plants and also animals, because it represents a refuge for a very, very big number of animals, smaller one and also large animals. It play a role, important role for protection, protection against natural disturbances and also against human-induced disturbance. And also it is an outdoor laboratory, or if you prefer, the living lab for students and for researchers, within which you can observe forest dynamics and you can understand which are the relationship among three species and among three species and animals and also human needs. So you can observe the dynamics, the growth rates of trees, and you can also assess the growing rate again, and the impact that human has on the trees and on the forest through the forest management and the forest harvesting activities. So it is also a very useful place, beautiful place where you can spend some moments with the touristic and the recreational activities. So there are a lot of a huge panel of ecosystem services that forests provide, and we need to manage that forest in a sustainable way in order to ensure the provisioning, the continuous provisioning of these ecosystem services in order to promote the human well-being. So there are the concept of sustainable forest management that aims to support decision maker and forest managers to manage in a correct way this forest ecosystem in all the parts of the world. Of course, we are lucky because in Italy, we can say that the management of a forest is rather positive respect to other places in the world. Even if we have a critical issue related to the import-export of timber products, because we have a lot of forest surface, but we do not use too much our forest, and we depend from timber from other regions, from other countries, and it is a critical issue at the national level. So we have to ensure the delivery of this ecosystem service, and we need to know very well our forest and the relationship and the dynamics of forest growth in order to better manage our forest. We have one third of land surface in Europe. It is covered by forest area with different forest types. So we have also a very large value, a very big value of forest biodiversity, in particular in Italy, because in the Mediterranean biogeographical region, it is worldwide known that there is a hot spot of biodiversity because the climate condition allowed to develop numerous living organisms and plants and animals. So we have a pool of biodiversity, and we need to protect, to manage forest in order to conserve this pool of biodiversity. So forests play an important role for store carbon. According to the last report of State of Europe's forest, we have more than 100 million tons of carbon stored per year in our forest. So it is a very, very box of carbon stored in the timber. And also the forest sector reach at least 1% of gross domestic product. So it is a very, very important resource also for producing income for forest owners and forest managers, specifically in the inner areas that I will show later a slide specific for inner areas and the marginal areas. In Italy, we have a situation which is similar to the situation that we have observed at the European level, with 12 million of hectares of forest surface, which correspond to more than 1/3 of total land area, most of this forest present an ownership which is private, and only 1/3 is public forest. So you can imagine that there is a different mosaic of different type of forest management depending on the forest ownership, and also there is another aspects that impact on the forest management, because we have a general framework of law at the national level, which is the testo unico in materia di foreste e filiere forestali. I don't know the translation in English. Yes, it is a framework, a general law at national level. After the TUFF, there is the National Forest Strategy, but there is an important aspect to take in consideration, because each region, included the autonomous province, has as a privilege, has specific rules for manage forest within the regional boundaries. So each region has a different forest law with different time and with different rules. And this contributed to enrich the diversity of Italian forests in terms of tree species composition and also forest management regimes. Of course, how you can say from the picture on the left, you can see that the forest surface is distributed on the main mountains of Italy, along the Alp chains and along the Apennine mountains. So these are the main area where we can found our forest. There are a lot of protected areas, so it means that not all the forest surface can be managed for timber production, but there is a huge part of a forest that can be managed for biodiversity conservation. And of course, considering the territory and the morphology of this territory, you can also imagine that not all forests are accessible for harvesting activities. So there are a lot of forests managed with protection. There is another aspect that we have to take in account, which is the increment of forest surface, because in the last 10 years, according to the National Forest Inventory data, there is an average increment about of 6% of forest surface in Italy, and our region, Molise in this case, is the region with the highest value of forest increment. So I said that I will show an image about the inner areas. There are 72 inner areas identified at the national level, and these areas are characterized by law of essential services, within which forest resource often is the main or is the most important source of income for this area. And as reported also in the National Forest Strategy, we have to promote the use of this forest for providing, for developing forest shine in order to provide income for the forest owners and to revitalize the local economy. And this is an example of a forest shine that aims to provide durable timber products in order to store carbon for a long time, much as possible, and also to use only the low quality of timber for producing energy, which is which is the most common practices currently across the Apennine mountains. So there is a need of changing of our culture about the harvesting activity and about the use of timber products, and we have to promote the development of timber products rather than energy purpose. It is a very complicated things, because we have, especially in the south part of Italy, we have a lot of oak forest, so the timber quality is not very good, and often the only timber assortment that we can obtain from this type of forest is firewood, so only for energy. And this is a way we need are changing in our culture, and we have to promote a different type of forest. We have to invest a lot on forest management in order to valorize the timber and to valorize the timber the timber assortments. In addition, there are several impacts that affects the forest resources. We know that there is the climate change that impacts negatively on forest resources, and of course we have to take in consideration this aspect, even because it is there are several scenarios that show that there will be an increment of natural disturbances. So in the next future, natural disturbances will increase, and the forest resources are threatened from these natural disturbances, within which the function that the forest play for human well-being will missing. So we have to react to this natural disturbances. We have to provide a solution in an early stage, because it is too late for managing our forest, in order to promote the production of forest ecosystem services. So we have to avoid that natural disturbances will impact in a irreversible way on our forest resource, because we need to have forest health and vitality in order to ensure the provisioning of forest ecosystem services. So this is why in the recent years we focus on two main approach that I will show later, in order to forefront these main challenges, which are climate change and forest biodiversity. So we have to reduce the loss of biodiversity, and we have to forefront the climate change and the negative impact that the climate change has on the natural resources. And this is why we need information. We need to collect data for improve our knowledge, for collecting information about forest resources in order to promote forest resilience and enhance the forest biodiversity. All this information are crucial for better manage our forest, and for developing management tools such as forest plan, in order to promote health, forest and forest vitality, and of course to produce high quality of timber products. One of the most important tools for monitoring forest resource, maybe you know already this picture. One of the most important tools for monitoring forest resource and for monitoring the trends of sustainable forest management is the set of criteria and indicators for sustainable forest management. I don't know if you already know these tools. It is a hierarchical tools composed from criteria at the highest level, which are 6 criteria. One for the forest surface and the global carbon cycle. One criteria focused on monitoring forest health and vitality. One criteria for forest productivity. One for forest biodiversity. One for forest protection, and one for socioeconomic function. For each criteria, there are several indicators, for a total of 34 quantitative indicators. Each one is monitored for providing such information in order to assess, to have an overall evaluation of sustainable forest management across Europe. So each countries in Europe provide data for each of these indicators in order to produce a report about the state and trend of forest resources in Europe. You can find this trend at the link Forest Europe, which is the organization that developed this report. And also from this link, you can download the list of criteria indicators. And if you are curious, you can see also the historical evolution of this set of criteria indicators, because At the beginning, the number of indicators was lower than the current set, and then after several meetings, after several conference, they developed this final set of indicators. There are criteria, there are quantitative indicators, there are also qualitative indicators, which are at least 10 or more or less 10, but usually I don't show the qualitative indicators because are more subjective to monitoring. But I prefer to use to show the quantitative indicators because it is more the evaluation of the quantitative indicators is more objective rather than for the qualitative indicators. So if you are interested to see the value of each indicators, you can download the report from the Forest Europe site. And as I already mentioned in the previous slide, sustainable forest management is a well-known concept adopted worldwide, which is based on the three aspects: economic, environmental, and social. And in the last year, there are two new approaches for sustainable forest management, which are climate smart forestry and integrative forest management. The first one is more oriented to counteract the climate change, while the second one, the integrative forest management, is more oriented to integrate the conservation of biodiversity within the traditional silvicultural practices. So I will show you more in depth this concept before to pass in the description of on the tools for monitoring forest biodiversity. So the climate smart forest is a new concept developed during the last decade. It started from the concept of climate smart agriculture developed from FAO, and it is aimed to promote adaptation, mitigation, and social dimensional strategies in order to manage our forest. So the basic of the concept is that we have to implement management strategies, forest management strategies aimed to promote forest adaptation, forest mitigation, and also to ensuring the provisioning of ecosystem services. In this case, also the social dimension was included in the definition climate smart forestry. This definition was developed during a cost action project, which was named Climate Smart Forest in the mountain region. And it was a cost action project that involved 28 EU countries, within which the representative of these countries developed this definition that you can read in the first blocks, which is climate smart forestry is a sustainable adaptive forest management and governance to protect and enhance the potential of a forest to adapt to and mitigate climate change. The aim is to sustain ecosystem integrity and function and to ensure the continuous delivery of ecosystem goods and services while minimizing the impact of climate-induced changes on mountain forest, on well-being, and the nature's contribution to people. So in summary, as I already said, we have to integrate the mitigation, adaptation, and the social dimension when we have to consider adaptation, mitigation, and social dimension when we manage our forest. Of course, in my opinion, it is my personal opinion, we have to avoid to create a forest museum. So unmanaged forest for me is not a solution for promote climate smart forestry, but we have to introduce new tools for assessing, for collecting information timely in order to react immediately if some natural disturbances or if we can predict the occurrence of some disturbances in order to promptly react and promptly implement some forest management strategies. And if you want, we can stop now to avoid to be too boring.
Okay. Thanks a lot, Giovanni, for this introductory part. Let me just add on top of what you just said. on the last concept. Basically, the bottom line is, can we, at a larger scale, ensure that all the benefits from forests are maintained throughout forest management in the same forest management unit? The answer is no. So usually in forest management plans that are implemented over larger areas than the forest management unit, we integrate, we complement, we merge, we combine several objectives, several forest management goals, but over larger areas, okay, including biodiversity conservation. So usually we have a landscape scale, a parcel devoted to timber provision, a parcel devoted to hydrological protection, a parcel devoted to gaming, a parcel devoted to non-wood forest products, a parcel devoted to biodiversity conservation, okay? It's hard to ensure that forest management fits all objectives in one solution, okay? So let's have a couple of questions on board. From here in presence, is there any question on the introductory part? Yes?
Very interesting presentation, Matteo Malfatti, a researcher here in Unimont. I noticed that you talk about 6% in Italy of increasing of the forestry. Could you give some info, added the info? It is related more because we stop agriculture in some region, because I see that the main region are in south of Italy that have this increasing. And so how this could be managed? So which are the motivation and which could be completed with? And the other thing is related to how is managed differently by the municipality and by the private sector, and how the private sector versus the municipality property could practice this methodology, and so which is the difference in the acceptance to promote their sustainable forest management.
Okay, thank you very much for the question. So the first one is yes, is the increase of forest surface depends from the land abandonment. So most of the marginal areas, such as the inner areas, are continuously abandoned from people, from young people, so from the power, the workforce, and the consequence is that the agricultural areas become forest areas. So there is an increase of forest because the agriculture is missed in several parts of central and southern Italy. The second question is related to forest management, about the private owners and the public owners and how they can accept each other. Okay, in my experience, we test 20 years ago through pilot studies the territorial forest plan, so the forest management plan at the territorial level. So this could be a solution for integrating several private forest owners, to merge several private forest owners, also with the public forest owners, in order to define a common objective and to reach this objective through common forest management strategies. So identify some specific area which are more prone to produce timber, high quality timber, rather than such area more prone to conserving forest biodiversity. And you can reach this common objective managing the whole forest, considering the landscape level and not only the individual forest owner. So this is my idea. Yes, And there is also some experience in the center Italy. Maybe you know the forest sharing startup. It is a very young startup that collected several forest surface within which the forest owners has no force, has no people that want to manage or which are able to manage this area, or maybe the forest owner is disappeared, that there is no physical forest owners. So maybe there are some forest managers that provide this forest surface to this startup, and the startup will take care about the management of this forest with a landscape vision and not with a single, I would say, single ownership. Because sometimes this is a general characteristics of all Italy. Private forest owners has very small forest patch, forest surface. So it is difficult to, I would say, to ask the private to has a management plan for each forest area, but it is more easier to merge this area all together with also with the public forest and to implement a forest management plan at the landscape level or at the territorial level, as is named. In this case, you can develop management strategies which are effective, which has an effect on the forest management, and you can, I'll say, you can touch the results of this forest management.
Let's check whether there is any question from people connected remotely. You might also pose your question on the chat if you wish. No, okay. So Giovanni, let's continue. Thank you. Alessia, grazie.
Okay, so we have now, I would like to introduce the integrative forest management approach, which is the second one that I have already mentioned, and it aims to integrate the conservation of forest biodiversity within the traditional silvicultural practices, which means to take care of specific aspects, specific issues about the forest biodiversity when you harvest forest area. So you have to retain some specific elements which are important for forest biodiversity in order to ensure the conservation of biodiversity. So this is the triangle that the integrated network developed, trying to explain with this picture the concept of the integrative forest management, which merge together practices with research and with policy making, because we need to develop knowledge in order to implement some innovative solution, in order to give support to decision making, in order to develop useful forest management strategies. So of course, it is not related strictly to timber production and forest biodiversity, but it is related to the provisioning of, in the same time, in the same area, forest biodiversity on one side and other ecosystem services on the other side. The ecological elements that were taken in consideration are the three related microhabitats. I don't know if you already know this name. Maybe some of you already is familiar with these terminologies. They are ecological features that occurs on the trees, on the standing trees, both living trees or dead standing trees, and which are very important because they represent an habitat, a crucial habitat for several living organisms, microorganisms, insects, and also animals, mammal, or or other animals. These are epiphytic and epixylic structure. It can be cavities that will occur at a different height of the trees, on the crown, on the trunk, at the bottom of the trunk. It is a crown deadwood. They can be excrescences or such defects of the trunk related more to the tree morphology. They include the tree injuries and exposed wood and several other ecological features. Here, I have reported some pictures that we encountered in the forest with the fungi, with the dendrotherms, with other type of fungi, or whole tree habitats, because the presence and the abundance of tree-related microhabitats on the trees characterized these trees as habitat trees, which is very important for conserving biodiversity within the forest. So, recognizing the important ecological role that these ecological features have for conservation of biodiversity, there is a team from EFI that developed in cooperation from researchers from INRAE, developed a catalog of tree related microhabitats. It is a field guide, useful, very useful when you carry out forest inventory activities in the field. So you have this small book, pocket book, that you can use to identify the tree related microhabitat. There are in this catalog 64 different types of microhabitat classified according to these categories: cavities, injuries, bark, deadwood, deformation or morphology of trunks, epiphyte, nests, and other microhabitat. For each of these categories, there are several microhabitat types for a total of 64 types. Most of them are very similar. The only things that change is the size of the microhabitat. Maybe the cavities, there are cavities lower than, with a diameter lower than 5 centimeters, and the cavities larger than 5 centimeters. Or there are cavities on the top of the trunk, or in the crown, or also can be cavities at the bottom of the trunk. So there are the position, the sides that classify these microhabitats. And they are very, very important because such microorganisms, such insects, will find nutrition within this microhabitat, will find refuge within this microhabitat, and will spend part of life cycle within this microhabitat. This is the reason because at the European level, but now also at the global level, there is a very huge interest about this topic of forest monitoring, because they have recognized the ecological role that this microhabitat play for conservation, for conserving forest biodiversity. Of course, you can find this catalog at this link, but if you wrote on Google microhabitat and the catalog of microhabitat, you directly will be linked with the site of integrated network and with the catalog of microhabitat. There is also an application for a smartphone and for smartphone, yes, for Apple and also other Android and etc. You can download this application and you can identify different type of microhabitats. And I will show later how to do this. Subsequently, after this field catalog, a researcher from INRAE in France developed a hierarchical typology of this microhabitat. So refined the classification according to this scheme, with this picture, with this representation. And the hierarchical framework includes 7 forms, 15 groups, and more than 50 types of microhabitat. The only difference between this classification and the previous one is the size of a microhabitat. So the type of microhabitats are the same. The only things that changes is the size, and of course the name of categories. You can find this classification in this paper, which is published in 2018, if I remember well, from Laurent Larrier, which is a researcher at the INRA in France. And here there is a very short presentation of the martelloscope, because when there was a recognition that tree-related microhabitats are very useful ecological feature to be retained in the forest for promoting the conservation of biodiversity, the European Forest Institute launched a project named the Integrate Project, aimed to develop a network of martelloscopes across Europe, within which researchers developed the field activities, forest inventory activities, and mapped each trees within 1 hectare square area, 1 hectare square forest, and behind the forest inventory activities, also the microhabitat will be observed, identified, and mapped. So this area is called the martelloscope, and I will, yes.
Before getting into the video, let's say that I think you have received a newsletter from Unimont. There will be a demonstration activity on martelloscope area here in Edolo, physically on 14th, next week, on 14th of May, which will be in Italian, and it's kind of presentation the day before, so on the 13th, okay, on the martelloscope. But just a quick break on this. I don't know what on this section of the webinar. Giovanni is just now framing the assessment of biodiversity within the monitoring activities. Why is monitoring of forest and forest health status so important? Because if we need to plan the management activities and implement them over space and across time, so we need to know our forest. So we need to know the health status, we need to know how the components of the forest are distributed across the space. What's the competition? Which are the key aspects or elements composing this ecosystem? This would help a forest manager or planner to implement in the most effective way the management activities, and also a kind of forecasting the effect of the management activities on these elements, such as, for example, microhabitats. Moreover, just a very brief addition on this, you have recognized that the detection of microhabitats is an indirect measure of the biodiversity, of forest biodiversity. So we don't count and check the number, for example, the number of individuals composing a certain species or genre, okay? But we are assessing, evaluating their houses. So the place where these microorganisms live, okay? So you understand this, which is it's not really a shortcut, but in terms of cost benefit opportunities for a person who is going to monitor this kind of aspects of the forest ecosystem, this is important, because this framework can be embedded, as in the martelloscope area, within our larger monitoring network, so can be included and integrated with other field surveys, okay? For example, the dendrochronological surveys that we usually do in forest inventories in our forests, okay? So this is really a cost benefit opportunity, so the use of the microhabitats as a way to assess biodiversity, just to promote a more effective forest monitoring activities in our size. Sorry, John.
Yes, you are right, because we said, every time we say the forest biodiversity, but to be honest, it is a forest potential biodiversity, because we, as Matteo said, we count the number of places where potentially we can find insects or other animals that benefit from that habitats. So I will launch this video, and then I will come back on the description of martelloscopes.
SketchUp 2024, il nuovo videocorso è pronto per questa nuova release.
A martelloscope is a forest stand of 1 hectare in which all trees have been inventorized. So we record 3 species. This is an oak. We number them 132. We record size, wood quality distribution, and also very importantly 3 microhabitats such as deadwood, woodpecker holes, and fungi, etc. All this information is then inserted into a map that gives an overview of the stand and that allows us to do virtual thinnings and practice forest management.
Very short because it is a challenge of 30 seconds that Jacobs made for the EFI. So I talked about the integrated network and about the network of martelloscope. The martelloscope is a 1 hectare square areas within which all the trees will be mapped and identified for the 3 species, for the diameter, for tree height, the crown length, and also the identification of the microhabitat. So for each trees, we can know the economic value according to the market value based on the 3 sides, and the ecological value or habitat value based on the number and the diversity of microhabitat that occurs on the trees. So we have on one side the habitat value and on the other side the economic value. And within the martelloscope, which is a demonstration site, we bring students and forest operators to hypothesize such silvicultural interventions in order to evaluate the impacts of this intervention in terms of money, so euro, or in terms of habitat. So which each silvicultural interventions has an effect, has an impact on the economic and habitat value. And so we can, after this exercise in the forest, we start with the discussion and to compare different opinions about different stakeholder categories, often with conservationists versus forest managers or versus forest students. And then throughout the discussion, you can improve the knowledge about the dynamics of a forest relationship, about forest competition, tree competition, and so on. So this is the current network of a martelloscope. There are more than 250 across Europe. There are several martelloscopes in Italy. Then I will show the position. And I know, as Matteo said, that next week will be introduced a new martelloscope here, close to the Edolo. Our colleagues from University of Georgia, with the support of students and with the support of the DREAM, developed this martelloscope. And this is an example of the meeting, the annual meeting that we have across Europe within the integrated network, because the integrated network is it is not an association, it is just an organization within which the representative of countries, each country of the European countries, have several meetings online during the years, and at least one per years we meet in a different place in Europe to converge, to discuss about the improvements and the usefulness of a martelloscope network and other activities within the forest that aims to promote the integrative forest management approach. So these are the martelloscope that the University of Molise already established in the center-south Italy with the support of also of the Matteo and some years ago. This is the tablet with the martelloscope maps, within which is possible to make the field exercise, within which you can select the trees that you want to cut or that you want to retain in the forest. And then for each trees, you know, as I said before, the economical value and the habitat value. So you can, at the end, you can count the volume, the timber volume that you harvested, the timber volume that remain in the forest, the habitat value that you harvested, so you remove it, and the habitat value that remain in the forest. And then you can compare and you can evaluate your choice and the choice of different forest stakeholders. The network in Italy is enriched in different regions and also in Lombardy now, also thanks to the support from the GoPro4 project, which is coordinated from DREAM, and the new version of the GoPro4, which is named the GoPro4 Med, which extended the network out of the Italian boundaries. So also in the creek, in the other place of East Europe. These are a picture of the microhabitat that we founded in our forest close to the University of Molise, and this is an example of the demonstration activity that we made with the students of different age and of different levels, from the elementary school to university students. So each students remain very, very enthusiastic after the field trip, because they saw a different shape of biodiversity, because they have to image the animals, the insects that can be use that habitat, and sometimes they found some insects directly in the microhabitat. So especially the young students remain very, very enthusiastic. This is an example of the illustrative description of the martelloscope that we put at the beginning of the martelloscope in order to inform people that visited that place that there is the university inside, that there is the university behind that project, that it is a scientific project, that we mapped all the trees, that we know very well this area. In our case, we put also other instruments for monitoring other aspects of forest growth, of the forest monitoring, and we consider that provide an informative label desktop that inform people that visit the place is very, very useful for linking the general public with the forest biodiversity in order to promote communication, and also to make, I'll say in English, sensibilization, yes, to sensitize and to become familiar with the forest biodiversity. And if you go on the site of Integrate Network, in the link at the link Martelloscope site or demo site, you can download some very, very short brochure, descriptive brochure, within which you can find the forest structure, so which is also a parameter of a forest complexity, if you want, because there is the DBH classes and the number of trees within the martelloscope, such general information about the forest description, and the number of microhabitat and the different microhabitat that was found, was identified within the martelloscope, with the map of martelloscope. And there is an application for smartphone and for tablet, within which you can make the game on the selection of trees that you want to retain, and you can visualize the impacts and the effect of your intervention in terms of euro and in terms of habitat value. So we can start now with some case study. We realized in 2016 the first martelloscope in Molise. It is a mixed broadleaves forest with more than 10 tree species within the forest. Each colors represent one different tree species. And we, after the After that, we have mapped all the trees, collected the information about the tree size, so DBH, tree height, crown length, and the indirect measurement, basal area, timber volume, and so on. We identified and counted the number of microhabitat occurred in that area, and we hypothesized some silvicultural interventions, promoting the conservation of biodiversity rather than promoting the to change the forest structure in that case, because it is a complex forest structure, the uneven-edged forest structure, and maybe with some intervention you can modify this structure, promoting the even-edged forest structure. And we, to be brief, we hypothesized 4 different forest management interventions, and we evaluated the impacts of this intervention in terms of habitat value, in terms of economic value, and in terms of forest structure, so the 3 diameter distribution. So we have the current value, which is the first line, the scenario 1, within which we removed the, such trees based on the basal area value, so only the value on the trees which basal area smaller than such thresholds. The scenario 2, the scenario 3, and the scenario 4, the X line here you can see the trees removed, and here you can see the impact, the effects of the intervention in terms of habitat value and economic value. Of course, more is bigger the size, more is the economic and the habitat value. If you are interested, you can download the scientific publication on the iForest journal, and this is the title of the publication. Another case studies focused on the similar interventions, but in that case, we used the 3 management types. One is the to leave the forest unmanaged, so totally absence of forest harvesting. The second one is to promote or to implement a close to nature interventions, so minimal interventions with very, very low impacts of interventions in terms of timber volume or basal area. And the second one is a combined forest management system, which promote the production of timber more than close to nature, and of course very, very different from unmanaged. And we repeated this exercise in 3 different martelloscopes, one in Lazio, Regione Lazio, Campegli, one in Molise, Bosco Pennataro, and one in Calabria, Gifone. So this is the acronym of the name for each box. And we observed that in some cases is the unmanaged forest management system that promote the occurrence of microhabitat, because we developed we adopted machine learning algorithms to evaluate which forest inventory variables was more impacting, was more influencing on the occurrence of microhabitat and on richness of microhabitats. And in Campegli, we observed that unmanaged forest management is that forest management system that promote the higher number of microhabitats and the higher number of microhabitat types. In Bosco Pennataro is a different forest, because of course the starting point of the tree forest was different. So in this case, it is even-edged beech forest, young beech forest. Here is a mixed broadleaf forest, so it is an even-edged forest, and in Gifone is a mature even-edged beech forest. And we can observe some difference in terms of results, in terms of occurrence and richness of microhabitats. I don't know, Matteo, if you want to add something, because you also took part in this work. Maybe later you can. So the last, it is not the last one, but we also used the identification of a microhabitat within a research project. We mapped and monitored the microhabitat in 60 circular plots with different aspects and with different altitude in a municipality forest. And we correlated the occurrence and the diversity of a microhabitat with the abundance of insects, of beetles, within which we make a discrimination from beetles we included in the UCN red list and which beetles without the UCN red list. And we identified some specific correlation among specific microhabitat with such insects. So it is a very, very interesting study. It was the first one study that identified the specific correlation with individual microhabitat and insects. So at the beginning of the seminar, we said that we talk about biodiversity, but it is more appropriate to say potential biodiversity. But in this case, we monitored also beetles, and so we can say that, okay, there is the correlation, and we demonstrated this correlation with this matrix. And it is very, very interesting study. And this is the last case study within which we developed a spatial index of microhabitat based on the presence and the diversity of microhabitats. So we mapped each trees with the tools that we use also tomorrow, the field map. So for each trees, we know the geographical coordinates, and knowing these coordinates, it is possible to make evaluation, calculation of the average distance among trees and the spatial partner of the tree horizontal distribution of trees. Based on this distribution, we gave a value of habitat based on the number and the diversity of microhabitat occurred on each trees. And with this formula, we were able to develop this index that give a value of 1 if each trees presents at least one microhabitat, and all the microhabitat reported in the catalog were present in the forest. So the value 0 if any trees has microhabitat, and the intermediate value based on the abundance and the diversity of microhabitats. So in this case, we have an index of 0.31, within which half of the habitat are habitat trees. So this means that at least as one microhabitat for half trees in that forest, or also an index equal to 0.18 if half number of trees as microhabitat, but only 10% of 3MS reported in the catalog are present. So in the catalog, there are 64 different types of microhabitats. This means that in this case, there are 32 64, more or less 6 microhabitat types. Otherwise, in this case, we have a similar value of 0.51 if half part of trees present a microhabitat and half number of microhabitat are present in the forest. If I am not clear, please interrupt me, because I can change my words and I can explain better. So it is a combination of number of trees, number of habitat trees, number of microhabitat, and number of microhabitat present in the trees. Based on this formula, this ratio, we were able to generate a potential biodiversity index. This study is unpublished yet. It is submitted to a journal. I forget the name of the journal because we submitted this paper 6 months ago and we are waiting for the revision. So now we can make the stop.
Okay, thanks a lot, Giovanni. Okay, as we have seen so far, so we have a double measuring of forest biodiversity through the microhabitats. So we have the number of microhabitat types, and this gives you kind of richness of this biodiversity, okay, indirect measure of biodiversity. More is the number of habitat types, more is the variety of these habitats, more higher is the potential that these habitats can host different species, okay? And then we have another measure of these microhabitats, which is the number of habitats by type. And this gives you a measure of the abundance of one or more habitat types in a certain site, okay? So you see you have this double measuring of forest biodiversity by microhabitats. So it's always a combination, as just showed in this slide. It's always a combination between the variety, so the richness of biodiversity, indirect measure of biodiversity, and a measure of the abundance of biodiversity. It's more or less like we count the species. On one hand, we have the number of species, so the variety of species, so the species richness, and on the other side, we have the species abundance. By species, we have a certain number of individuals, okay? And this is an indirect measure of these houses, these places where these organisms lives. And these organisms can be small mammals, birds, insects, micro arthropods, other very small, okay. And usually there can be a relationship, and this is more a question to you. Can it be a kind of relationship between the type of habitats and a certain species living in that habitat?
Yes, there is. This is an example of the specific relationship between such kind of microhabitats at the group level, at the type level. If you remember the typological classification, hierarchical classification in forms, groups, and types. Oh, this one. Forms, groups, and types according to the Larieux et al. So we make this exercise to identify the correlation between two levels, at the group level and at the type level, in order to identify specific correlation. Because as I said before, during the summer of 2020, I think, or 19, there is a colleague that used fly trap, wind trap, for collecting insects within the forest. So we have 60 plots distributed in this area, 15, 15, 15, and 15, with different aspects and with different altitude. So we have the low south, low north, 8 north, and the high south. Our colleague positioned the 60 fly traps in 60 plots and collected the insects during the summer of, I said, 2020 or 2019. And in the same time, we collected the information about the microhabitat. Of course, also forest inventory data, so DBH, tree height, and so on. And then we used the machine learning algorithm to identify which forest inventory variables were able to predict the abundance and the diversity of microhabitat and which relationship there is between the real presence of insects after the classification of the 200 of insects and with the presence of microhabitat at two hierarchical level. And we identify this, this correlation. The stars means that there is a strong correlation between the CB4 and beetles abundance, and also between CB4 and beetles richness. So also from GR1 and subroxylic beetles abundance. And the difference is that these are included in the IUCN red list, and these are symbol beetles without a red list. So yes, there is the correlation. Of course, it is difficult to observe because you need several measurements and observation, and I have not idea about the cost. Yes, but there was an activity within the research project, so with a life for climate, and in this case we can do this. But if you wanted to start a new observation, a new project, I don't know the cost, because the fly trap cost and also the forest inventory has a cost.
Okay, thank you. Let's check whether there is any question from the room here. Okay, wait. Grazie.
When there was the slide on the martelloscope, there was economic value in euros, I guess, but the habitat value, which is the unit scale of unit?
Good news. There is a reference value developed from EFI for which each microhabitat has a point value. It is not, I'll say, there is not measurement units, but just the point value. So here, okay, if you can read here, this martelloscope, without select any trees, you can read here 376 cubic meter, which is the timber volume. So based on the place, on the tree species, we can add an economic value. We can calculate the economic value, also based on the timber assortments, which depends from 3 sites and 3 morphology. For habitat value, there is a value equal to 2,922, which is just the sum of the points assigned to each microhabitat. And the European Forest Institute developed this Excel form within which there is the value for each microhabitat. When you implement a martelloscope, you have to fill in this Excel form and to send the data to the European Forest Institute, which is there is people engaged for make the calculation. You have to indicate if the trunk is only for firewood or if you have also timber wood for high quality timber. So with a different value based on the marketplace of your place, of your town. So if you have a red oak, is a different that if you have a Quercus pubescens, for example, and also based on the 3 sites. When you discriminate the timber volume for of high quality timber and the timber volume for firewood, you have a value for high quality timber or industrial timber and firewood, and you at the end have the value, economic value for each trees. And in the same time, for each microhabitat, you have a point value, habitat value. You're welcome.
Da casa no, però.
Okay, if I understand correctly, this is an analysis based on 1 hectare. So very specific. How is scalable these things on similar forest and so in the area? Because if I understand, or there is some study, because I understand that is a sort of research project or research activities. There is some study to figure out a statistical evaluation of all the forest that is related, that have similar characteristics. So as an example, if I have 50 acres or 100 acres that is similar, it's something that is scalable with certain margin or statistics, or we have only measure each hectare with 100 martelloscope.
Okay, good question. The martelloscope has the aims to teach, to train forest operators. So we use the martelloscope to bring a forest technician and to make simulation. And sometimes, often, when you select a place within which you want to implement the martelloscope, you have to select the most representative area, even if it is very useful to have a more rather accessible area, because if you want to carry out demonstration activity, you need the accessibility. Otherwise, you fail. I will show later that we tried to make an operation of upscaling, starting from the sampling scheme, within which we collected information on forest inventory variables and microhabitat, and then we made an operation of upscaling, drug the predictive models using machine learning algorithms, and after the drone that we collected information on wall to wall on the wall surface, on the wall of forest. So it is possible. Of course, there is a rate of errors.
I think there's a question from chat. It talks about the soil compaction impact on the conservation and biodiversity. Giovanni, do you want to reply?
Okay, if I understood good question, she said, ask if there is an impact of harvesting activity on the soil biodiversity. Of course there is, because harvesting activity is a disturbance, human-induced disturbance. If you make correct operations, these impacts will disappear in few time, in a very, very short period, maybe some months. But of course, if you make wrong operation, maybe you carry out harvesting activity during the rain period, or when the soil is not very, very dried, but it is rather wet, maybe you impact negatively on the soil, and the nature has required more times to restore the original condition. I hope the answer is good. Okay.
Okay, I think we can move on to the next and last block.
Yes, this is the third block and the last block of a presentation, focus on the innovative tools that we use for monitoring of forest resources, starting with the field map that we will use tomorrow in the forest, until to use the drone, terrestrial laser scanning, and tree talkers, which are all of these are instruments very, very useful for monitoring forest information, forest resources, and collect data about different aspects of a forest. Field map is more focused on the position of the trees, and it will be able to collect the geographical position of the trees, and of course all the information which can be georeferenced, such as the shape of a crown, the volume of the crown, and of course it is a digital tools within which there is a database inside, and you can fill in the database, including information about the microhabitat or how say vitality of the trees and so on. It is a field geographic information system. So the main characteristics of this instrument is that it's possible to georeferencing trees with high precision. When we bought the instrument, the enterprise said us that the precision is equal to a few millimeters. In the field is a little bit different, but it is a very, very high accurate measurement. And also it gives the possibility to see some preliminary statistics in the field directory, such as the number of trees and such as the number of tree species, the trees for each tree species, basal area, the dBH or average dBH, and also the number of tree species per hectares. You can make different size of plots in the field, and after that you can start with georeferencing elements within the forest. Elements, I means trees, crown gaps, maybe a river if you have, forest road, and so on. So each element that can be georeferenced. Also, you can see some statistics such as the dBH distribution and the hypsometric curve directly in the field. And it is very useful during the forest inventory because you can already know the forest structure directly in the forest. Being a field geographic information system, it is possible, it is very easy to move this information in GIS software such as QGIS or ArcGIS or so on, and you can manage this information within the GIS software. So you can improve and add further information, or you can make overlap with other overlaying with other shapefile and so on. So you have a geographic geodatabase, a geographic information with the database of forest inventory information. And since 2012, 90% of field activity that we carried out, we used field map because for us is very, very common to use it because it gives the possibility to also to make the elaboration about the tree species competition, such as the spatial index of tree-related microhabitats or other biodiversity index, such as the Gini coefficient, the Clark-Evans evaluation, and so on. So the spatial partner of the tree distribution within the forest. The drone, you know very well, I think, because it is very, very common to use drone for forest monitoring. And in a previous project, in a live project called the Trash, we used two types of drone, the EB, which is this one with a multispectral camera mounted on board, which allow to collect digital information, image, multispectral image, within which we use it for discriminate living trees from dead trees or partially dead trees or dead crown. So forest health and vitality is one of the criteria indicators that I mentioned before, and tree vitality in this case was monitored using this multispectral image. The image has a spatial resolution of 10 centimeters, so the pixel was 10 centimeters for 10 centimeters, so very, very high resolution. In this case, we used the drone, but not with the multispectral image, but with the LiDAR sensor. LiDAR is an active remote sensing sensor because launch several pools and collect the return signals, and based on the velocity or the time that occurs between the launch of signals and the reception of the signals, the tools allow it to calculate the geographic coordinate of each point. So at the end, we have a cloud of point clouds with millions of points within which we know the X, Y, and Z coordinates. So the latitude, longitude, and elevation. And at the end, we use this information to reconstruct the three-dimensional shape of a forest, the forest structure. And also we can calculate the timber volume and the other forest inventory variables. Of course, we need the integration of some field inventories, traditional inventories, in order to calibrate the instrument to improve the resolution, the accuracy of measurements. In this case, we use the cloud point to calculate and to represent maps of timber volume and the carbon stored in the forest. And also to, at the end, the last products of the project was the forest management plan, totally developed with LiDAR instrument. In this case, we used the airborne laser scanning, so even in this case, the LiDAR information, so the cloud points, to spatialize, to assess the abundance of microhabitats and habitat trees. So this is the answer of your question, because we were able to upscaling the information collected in 50 plots within 200 hectares of a forest. So we, at the beginning, developed an assembly scheme dividing the whole forest in 50 clusters. So 200 forest, 200 hectares of a forest was divided in 50 clusters. For each clusters, we select one point which a surface of 513 square meters, and within which we collected forest inventory variables, such as the position of trees, geographical position of trees, DBH, tree height, crown length, and the microhabitat. Thereafter, we used the machine learning algorithms to identify which metrics of cloud points, LiDAR points, fitted better with the forest inventory variables. And then we used this correlation to replicate the correlation of wall-to-wall analysis in order to obtain this map. The white points are mistakes because I have to say everything. In this case, we did not use the drone, but we used the helicopter. And it was not, I'll say, a fly plan, but there was a pilot of helicopters that drove the helicopters without the fly plan. So in such case, there was not overlapping about tips. And this is why there are some white areas without information. So it was a mistake of the operators during the fly. And with the same approach, in this case, we mapped the presence we predicted the presence of habitat trees, and in this case, the abundance of microhabitat. So the same approach through the machine learning algorithms, identifying the correlation between metrics obtained from LiDAR cloud points and forest inventory variables. This is another instrument that we started to use last year. It is a terrestrial laser scanner. It is again, it is a LiDAR sensor, but in this case, it is not from the top down, as the airborne laser scanning, but it is terrestrial because it is in the field. And the principle was the same, but it works in horizontal ways rather than in the vertical ways. And it allows to reconstruct exactly the forest structure with millions of points for square meters, millions. And it is also as a RGB sensor, so it's possible to obtain the cloud points with RGB colors. So you have a three-dimensional reconstruction of a forest with real colors. And this is a video clip about this forest. And it is a very, very useful tool because it is possible to reconstruct the shape of individual trees, and then you can assess the timber assortments that you can obtain from the forest. Of course, it is difficult to map hundreds of hectares of forest, but you can use a sampling scheme for make the measurements. So from the cloud points of a leader, we were able to extract single trees, to discriminate the trunk, the timber from the leaves, and then to evaluate the carbon stored in the trunk, in the timber, and also the shape of the trees, of the trunk, and the timber assortment that you can use. Of course, if you have a linear trees, you can obtain industrial roundwood. If you have very, very deformed trees, only you can obtain firewood. The high resolution of LiDAR allows to map also the epiphytes and mosses and the hederas, and of course also deadwood. It is difficult to assess the decay stage of the deadwood, but if you have dead trees in the forest, you can map very, very quickly. And of course you can evaluate, you can measure the size of the trunk and the length, so you can quantify the volume of the dead wood in the forest, which is an important indicator of forest biodiversity, as reported also in the forest national strategies, and also it is an indicator for identify the old growth forest, so to characterize the old growth forest. And of course you can reconstruct, you can map also microhabitat, as in this case the cavity, or as in this case the growth form, as this excrescence. So there are a lot of innovation in forest monitoring. Of course, these instruments have a cost, but the quality of the data that you can obtain is very, very, very high. And of course, it is more easier to use it within the forest, within the project, the research project, rather than in the traditional technical activities. But I would like to highlight that it is important to merge, to collaborate with the technical part of the forest sector in order to develop common tools and the common approach for better monitoring of forest resources, in order to facilitate harvesting activity and also to facilitate the assessment of the forest quality and the timber quality. This is another example of the forest monitoring with the terrestrial laser scanning. I took this picture in Bosnia and Herzegovina last year. This is a snag in the forest, and this is the cloud point obtained with the LiDAR. And this is the picture that we made during the field activity in the forest. So this snag is the same. You can see the mushroom, the fomes at the base of the trunk. Very, very high resolution. And now the last tools for monitoring other aspects of tree growth, of forest monitoring, such as tree growth and the sap flow. We started last year, a new project. I made to install several tools named the Tree Talker across the Sentiero Italia, so covering all the national territory in collaboration also with the Unimi, University of Milan, and other universities of Italy. And the tools I made to, I don't know if the video will start. So the Tree Talker is a new monitoring tools that allows to assess the tree growth, the radial growth of trees, and the frequency and the velocity of a sap flow. So the translocation of raw nutrient within the trunk from the root to the leaves. And it has other instrument which are able to assess the quantity and the quality of light that penetrate in the crown, thanks to this spectrophotometer. The whole instrument has to be mounted on the trunks, and then these sensors allow to collect this information and send the information to a cloud, physical cloud, that will send the information a server, online server, and you can download this information directly from your laptop in the office. So you reduce the time to go in the forest for collecting information, and the sensors at the moment is calibrated to collect information which time frequency of 1 hour. So you can obtain 24 strings each day, and you can imagine that we are collected several million of strings. Okay, the video was stopped. So these are some pictures that we collected during the installation phase of these instruments. We started this research activity 6 years ago, installing 100 sensors, more or less, 95, in 5 different plots. And since last year, we aimed to enlarge this network to the whole territory, from north to south, including the Sardinia and the Sicilia. These are the string, and these are the code for elaborating the data. I will go on very quick. So these are the output that it provides. So it allows to collect information with a sampling rate of 1 hour. It allows to collect information on transpiration, subflow, on stem humidity, air temperature, tree stability, because there is an accelerometer within the instrument, and also the tree growth, the radial growth. Okay, this is the mechanism, the cloud, the server, and the laptop, and these are the strings that we obtain. Of course, we do not obtain directly the information that I'll say with the same unit measurements. So if I want to observe the radial growth, I have to not find here millimeters, but just digital number that we have to manage and elaborate with other scripts, secret scripts, for transforming this value in millimeters and so on. And these are some reports of this instrument. So temperature, subflux, and radial growth in these graphs. Some problems of this instrument, because I like to highlight the potential of this instrument, these tools, but also some problems, because frequently you have to go in the forest for replacing some sensors which are damaged from animals, squirrel, or other animals, maybe people, people, or meteorological agents, because the water or snow can go inside if there are some problem in the cover, and then you obtain this situation within which everything is damaged, and you have to replace some sensors of the wall instruments. So this is the new network of tree talkers belonging the Alps and Apennine Mountains, following the network, following the Sentiero Italia. And this is the schematic protocol for field measurements within each plots that we have to install in this new network. There is another tools that recently we used, that recently we installed on within the national park, which is the dendrometer, the BERT dendrometer, that allow to measure the radial increment. It is not digital as the tree talkers, but it is physical. So each 4 to 5 months, we have to go in the forest for downloading this data with the pen drive, and we can observe the fluctuation of the trunks during the period observed. So we have finished, and this is just the indication for tomorrow for the field activities. I know that Alessia already downloaded and printed the field catalog of microhabitat. So tomorrow we will go in the forest. We will implement some plots, forest plots, within which we collect information with the field map. So geographical coordinates of trees, tree diameters, tree height, crown length, and also microhabitat.
Okay, thanks a lot, Giovanni.
Thank you.
This was a very, very interesting presentation and full of content. I would say you touched many aspects related to not only to biodiversity as such, but also to monitoring the planning of the interventions, the impact of the forest management interventions on some of the aspects related to forest ecosystems. Before closing, I will leave some time for some question, if you wish. First from the room here, is there any? I don't know, curiosity, comments? No? Anyone from remote? Okay, so there seems you were pretty clear. Okay, just so let me close by saying something. Okay. Giovanni has touched some of the basic elements of and also innovative aspects related to monitoring of forest resources. The monitoring activities in forest resources are increasingly required, even from a policy perspective. Just an example for you, 2 years ago, the European Commission has adopted a proposal for the EU for a new EU nature restoration law, which aims to preserve at least 30% of the habitats in Europe, European Union, and with a particular emphasis on forest ecosystems. Some of the indicators that are currently detected by some of the approaches or devices or tools that Giovanni showed us regard the threshold posed by this regulation, this proposal for regulation, for assessing whether we are in a good track towards having a good conservation status in forest ecosystem. So monitoring is essential. So we need to collect as much as information as possible, of course, depending on scale and on costs. But it's essential to plan our intervention, foresee the effects of our intervention on biodiversity, ecosystem functioning, and ecosystem goods and services, in this case related to forests, and promote actions in the future that go in a direction of enhance, maintain, and or enhance the possibility to have the same productivity, the same availability of goods and services also in the years to come. Okay. Last but not least, I will really want to thank you all for participating to this workshop. Giovanni and people here, people connected from remote, and just to underline that this was, I think, a unique opportunity, especially for our students and all the students here in Edolo, to join these events. And this is only possible because we organize these events, okay, at Unimont by the university and at the University of Milan. And the topics treated during this workshop are fully embedded within our courses and our lectures on mountain forest. Okay, so stay tuned with other events, and thanks a lot again. Have a nice day. Bye.